Welcome students. Today we will start with exercise 2.3 of chapter 2 Polynomials. Now before starting the exercise, I would like you all to teach the polynomial division. How do we divide a polynomial with another polynomial? So let's see how do we do it. But the first and foremost condition for dividing is the degree of the divisor. The degree of the divisor means जिससे हम divide कर रहे हैं उसकी डिग्री हमेशा गिवन पॉलिनोमियल से कम होनी चाहिए. मीन्स इट शुड बी ऑलवेज लेस देन द डिग्री ऑफ द गिवन पॉलिनोमियल. Like if this polynomial given to me is of degree 2, then the divisor is of degree 1. And second condition for polynomial division, the divisor of the polynomial cannot have the degree as 0. The degree of the polynomial of the divisor should always be greater than or equal to 1. These are the two conditions required for the division of polynomials for the remainder theorem. What is remainder theorem? I will tell you later on. Now let's first see how do we divide a polynomial. Till 8th class you all have done division of numbers like 37 divided by 7, or I would say you divide 30 by 6, or you divide 500 by 10. So you have always divided numbers only. Now we will do division of polynomials by the long division method. This is called the long division method. So how do we do it? We are given the polynomial, so this is our dividend, and the number by which, or the polynomial by which we have to divide, is called the divisor. So qx is the divisor and px is the dividend. Now whatever answer we get after dividing is called our quotient, and the remainder left is called the remainder only as usual. So let's learn how to divide. So first we write the polynomial over here, 3x square plus x minus 1, and we are dividing it by x plus 1. So this is our divisor and this is our dividend. So we write it as usual, which we have done in division in the previous classes. Now how do we divide? See, the first term by which we have to divide, it should be equal to the first term of the given polynomial. Means we have to divide by such a number, means x should be multiplied by such a number that the answer is 3x square. Okay, means the divisor should be multiplied by such a number that the result is 3x square, or the result is equal to the first term of the polynomial. When you multiply qx, which is equal to x plus 1, by 3 into x, okay, what do? You multiply this x by 3 into x. So what will be the result? It will be 3x square. So this 3x is my quotient, because multiplying by 3x gives me the first term of my polynomial. So I am writing it 3x square, then I multiply 3x by 1 also. So 3x into 1 is equal to 3x. So I'll write it below the x term. Always write the like terms below each other. Okay, like terms should be written below the like terms only. So 3x square, and I have got over here 3x square, and over here it's x, below it I have written 3x. Now I will do the subtraction as you do in division. Always you subtract the number. So 3x square and 3x square are like terms with opposite signs, so this will cancel out, and over here you get 3x as minus 3x, and up it's x only. So minus 3x and x will give you the answer as minus 2x. Now I will bring down the remaining terms. So it's minus 1 only left, so I'll bring the minus 1 down. Now what is the first term of the polynomial left over here? it's minus 2x. So now I have to multiply this x with a number so that I get the result as minus 2x. So it's very clear, I will multiply x with minus 2. So this minus 2 becomes my question, and now I will multiply minus 2 with x, so I'll get minus 2x, and minus 2 with 1 also, so I'll get minus 2. Always write the like terms below each other. If there is some term which is not in the above term, you will write it on the right hand side. Don't write it below any other terms. So over here minus 2x and minus 2x cancels out because we are subtracting it. This minus sign will change into plus, and over here also minus 2 will change into plus 2. So I am left with plus 2 and minus 1, which is equal to plus 1. So this is the remainder. So as we used to write till 8th class, dividend was equal to divisor multiplied by quotient plus remainder. Similar way we can write in polynomials also. The dividend, which was the polynomial px, is equal to the divisor, which was qx, multiplied by the quotient, which was 3x minus 2, and add the remainder, which is plus 1. Now the remainder theorem. What does the remainder theorem says? It states that let px be any polynomial of degree greater than or equal to 1, and let a be any real number. Then if px is divided by the linear polynomial x minus a, then the remainder is pa. So is this clear? When px is the polynomial, px means the dividend, and x minus a is our divisor, we multiply it by the quotient, plus r of x is the remainder. Okay, remainder can also be in the terms of x. So what does it say? Let px be any polynomial with degree greater than or equal to 1. Okay. Suppose that when px is divided by x minus a, means when you divide a polynomial by a smaller polynomial with degree 1, then the quotient is qx and the remainder is rx. Okay, we have supposed all these terms. Let the polynomial be px, the quotient be qx, the remainder be rx, and the divisor is x minus a. Now since the degree of x minus a is 1, we have said in the statement of the remainder theorem, the degree of the polynomial is 1 because it is a linear polynomial. What a linear polynomial? Whose degree is 1. So again we are seeing over here, since the degree of x minus a is 1 and the degree of rx is less than the degree of x minus a. Okay, is this clear? Degree of rx is less than degree of x minus a. So the degree of rx is equal to 0. Clear now? Degree of remainder will always be less than the degree of the divisor. So since the degree of the divisor is 1, therefore the remainder will have a degree 0 because less than 1 is 0 only. So this means that Rx is a constant. So this is clear. Since the degree of the polynomial is 0 means it is a constant term. Let it be R. So let the remainder be R. So we can say it is R only because it is a constant term. There is no X in it. So thus we can write the equation first as P of x is equal to x minus a into qx plus r. Okay. So we can say that P of x is equal to x minus a into qx plus r. We have just replaced the rx in equation 1 by r. Because r is a constant, it does not have any variable term of x. In particular, if x is equal to a, we are considering a particular case in which we have taken the value of x is equal to a. So we can write it as P of A, instead of x I am putting A, is equal to A minus A into Q of A plus R. So A minus A will be 0. So this whole term turns out to be 0. So I'm only left with R. And exactly this is what the remainder theorem said. PA is equal to R. Now let's read the theorem again. Let Px be any polynomial of degree greater than or equal to 1, and let A be any real number. If Px is divided by the linear polynomial x minus A, then the remainder is P of A. So this is what I am saying. P of A is equal to R. R was the remainder. This theorem will become clear when we will solve the exercise and do the questions. Let's first solve the questions, then you will understand what I am trying to say. Now solutions of the exercise 2.3. Question number 1. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by, there are 5 parts over here. So let's start with one by one. So first part is x plus 1. So when you divide the given polynomial with x plus 1, what do we get? According to the remainder theorem, you can say that x plus 1 is equal to 0 or x is equal to minus 1. Okay? So now we will replace x by minus 1. Like we have done in the previous exercise, it's same. How to find out the zeros? We used to find out the zeros like this only. We used to equate the number with 0. So same we are doing over here. So I've equated x plus 1 to 0. So I got x is equal to minus 1. I've just transposed the side. So replace x by minus 1. We get x cube. Instead of x cube, I'll write minus 1 whole cube plus 3x square. I'll write plus 3 and minus 1 whole square. Plus 3x means plus 3 multiplied by minus x and plus 1. Now we will solve the equation. Minus 1 whole cube is equal to minus 1. Plus 3 into minus 1 whole square is equal to 1. Minus 1 into minus 1 is plus 1 only. So the result is 3, and plus 3 into minus 1 will give me minus 3 and plus 1. You can see all this cancels out and turns out to be 0. So the remainder is 0. So this is how we find out the remainder. And if the remainder is 0, that means x is equal to minus 1 is a 0 of this polynomial. We have done this part in previous exercise, hope you all remember. If the remainder comes out to be 0, then x is equal to minus 1 is a 0 of the polynomial. Now the second part, x minus 1 by 2. So again we'll do same. We'll apply the remainder theorem and we'll write x minus 1 by 2 is equal to 0. So this implies that x is equal to 1 by 2. You transpose the terms. So minus sign becomes plus. So it is x is equal to plus 1 by 2. So now we will put the value of x in the given polynomial. X cube. So I will write 1 by 2 whole cube plus 3x square means plus 3 1 by 2 whole square. 3x means 3 multiplied by 1 by 2 plus 1. Now 2 cube is 8, so I am writing this as 1 by 8. 3 multiplied by 1 by 4 whole square. 3 multiplied by 1 by 2 whole square. So 2 square is 4. So it comes out to be 3 by 4. Plus 3 multiplied by 1 by 2. So it is 3 by 2 plus 1. On solving these fractions, taking the LCM of the denominator, we get 1 plus 6 plus 12 plus 8 upon 8. and the total comes out to be 27 by 8. So the remainder is 27 by 8. So since the remainder is not coming out to be 0, that means x is equal to 1 by 2 is not a 0 of this polynomial. Now third question, x. You have to divide the given polynomial by x. So by applying the remainder theorem, I will write x is equal to 0. So there's no other term over here. So value of x by itself becomes 0. So now I will replace x by 0. So x cube means 0 cube plus 3x square means 3 0 square plus 3x means 3 into 0 plus 1. So all the terms become 0, 0, 0. I am left with only the constant term which is 1. In the previous exercise also I have told you all, if you replace x by 0, then the answer will be, or the remainder will always be the constant term only. So the remainder is 1. Therefore, x is equal to 0 is not a 0 of this polynomial. Now fourth question, x plus pi. So we will apply the remainder theorem same. X plus pi is equal to 0. X is equal to minus pi. So replace x by minus pi, we get x cube plus 3x square plus 3x plus 1. So minus pi whole cube. Instead of x, I am writing minus pi. It's x cube, so I am writing minus pi whole cube plus 3x square. So instead of x, I am writing minus pi whole square plus 3x. So I'll write plus 3 multiplied by minus x and plus 1. So minus pi cube becomes minus pi cube, because minus into minus will give you minus only, and pi raised to the power 3 will be pi cube plus minus pi square means minus pi multiplied by minus pi. So minus and minus sign becomes plus. So I am left with 3 pi square minus 3 pi, because plus 3 multiplied by minus pi will give you minus 3 pi and plus 1. So you can see over here the remainder is minus pi cube plus 3 pi square minus 3 pi plus 1. Now the fifth part, 5 plus 2x. So you will do 5 plus 2x is equal to 0. Same, you will apply the remainder theorem. I am not telling you this question, you will solve it as homework. Okay? You will apply the remainder theorem. You will write 5 plus 2x is equal to 0. Then 2x is equal to minus 5, or x is equal to minus 5 by 2. Then you will replace all the x by minus 5 by 2. So you will do this question by yourself. Now find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. So how will we find the remainder? We will write x minus a is equal to 0. We'll apply the remainder theorem again. So x is equal to a. We'll replace x by a and we get x cube. Instead of x cube, I will write a cube minus a x square. So again for x, I will write a plus 6x. So again for x, I will replace it by a and minus a. Now I will solve a cube minus a square into a will be again a cube. So it's minus a cube plus 6a and minus a. So the answer I am left with is 5a. So this is my remainder. Now question 3. Check whether 7 plus 3x is a factor of 3x cube plus 7x. So again same way we'll apply the remainder theorem and check. I'll write 7 plus 3x is equal to 0. This implies that 3x is equal to minus 7. I'll transpose the 7 over the right hand side. Then I'll get x is equal to minus 7 upon 3. I'll bring the 3 to the denominator. Now what is the value of x that we are getting? X is equal to minus 7 by 3. Now we will replace the x with this value. So by substituting this value in the polynomial, I will get 3 into x cube means 3 multiplied by minus 7 by 3 whole cube, plus 7x means plus 7 multiplied by minus 7 divided by 3. So I'll solve the bracket. 7 cube is 343 and minus sign multiplied 3 times, minus into minus will be a minus only, and 3 cube is 27. So I get 3 and in brackets I have minus 343 divided by 27. Then you get 7 multiplied by 7 is 49 upon 3. Now we will take the LCM and solve it. So we will get the answer as minus 490 upon 9. So you can see this value is not equal to 0. Therefore, this is not a factor of 3x cube plus 7x. For a number to be factor, it is necessary that the remainder is 0. This is what the remainder theorem states. For a number to be factor, r should be 0. The remainder should be 0. Since the remainder is not 0, therefore this is not a factor. Or I would say remainder is not 0. This implies that x is equal to minus 7 by 3 is not a 0 of the polynomial, or is not a solution of the polynomial, or is not a root of the polynomial. Thank you, student. So we have completed exercise 2.3. Now we will move on to next exercise. So complete all this in your copies and don't forget to practice maths.